Welcome to Lesson 2 on Sine Law word problems. In this video, we're going to continue on from our sine law from the last video and apply them to real-life applications. Before we begin and actually solving some word problems, I'm going to remind you of our sine law, which is sine A over A, where the large A is an angle and the small a is a side. This equals to sine B over B, which should also be equal to sine C over C. And we would usually just use two pairs using the sine law. So for example, I could be using sine A over A is equal to sine B over B, or I could also be using sine B over B is equal to sine C over C, or sine A over A is equal to sine C over C. So here's the first problem we're going to try. Elliot's family owns a house, and their closest neighbor is 2.5 kilometers away. So this is Elliot's house here. This is the neighbor's house, and the distance between those two is 2.5 kilometers. We also know the measure of the angle between the house and the nearby communication tower as shown in the diagram. So we know this angle here is 65 degrees, and this one here is 80. We're going to use a sine law to determine the distance from Elliot's house to the tower to the nearest tenth of a kilometer. So we're looking for the distance from here to here, because that's Elliot's house to the communication tower. So this is what we're looking for. It's going to be a little bit easier for me if I label my vertices and sides. So I'm just going to label Elliot's house as A, the neighbor's house as B, and the communication tower as C. Then I'm going to name the corresponding sides as well. So directly across from angle A gives us side A. Directly across from angle B gives us side B. And then directly across from angle C gives us side C. So the information that we know have to do with angle A, angle B, and side C. Now, if I'm looking for side B, I need a set of information. That means I need angle C and side C, or I need angle A and side A. And at this time, I have neither of those pairs. But we do have enough information to find angle C. So that's the first thing we're going to do. Just going to quickly redraw this triangle. And this is the scenario that we have. So I have two angles already, and I'm looking for the final angle. We know how to find this because if we add those three angles up, we should get 180 degrees. So then to find angle C, I'm going to take 180 and subtract the two angles I do know. So it's 180 minus 65 minus 80. So angle C is 35 degrees. Now this is our new scenario. We know this is 35 degrees, this is 65 degrees, and this is 80, and we know the distance between these two from point A to point B is 2.5 kilometers, and we're looking for this side, which is side B. Now I have two pairs, angle C and side C. And then I can use angle B to find side B. So this is what we're going to use. Sine C over C is equal to sine B over B. Again, that's because I have angle C and I have side C. And I'm looking for B, but I have the angle of B. So I'm going to go ahead and plug in the information we know. So angle C is 35 degrees, our side is 2.5 kilometers, the angle of B is 80 degrees, and we're looking for side B. So from here, my step to solve for B and isolate it is to cross multiply, and then afterwards I will divide. So after I simplify this, it's going to be B times sine 35, 2.5 times sine 80. Now in my next step, I'm going to divide. I'm dividing by sine 35 to isolate b. So then I'm going to divide both sides by sine 35. So that sine 35 cancels on our left-hand side. And this is what I'm going to punch in our calculator. So we're going to do sine 80 in the calculator first, multiplied by 2.5, press equals, then divide by sine 35. And you should get 4.3 kilometers. Make sure you try plugging this in on your own right now, just to make sure that you know how to get the answer by using your calculator. And if you have problems, please feel free to contact me and I can answer your question. So that is our final answer to this question. We can write this as a sentence. So the distance between Elliot's house and the tower is 4.3 kilometers. Remember to include your units because we are given a specific scenario. Let's try another question. So we have a pulley winch in an automotive shop and suspended from a ceiling by 2 support chains. One of the chains is 2.4 meters long and forms an angle 55 degrees with the ceiling. The second chain is 3.5 meters long. We're going to use the sine law to determine the size of the angle that the second chain makes with the ceiling to the nearest degree. So what we're looking for here is the angle that the second chain, this is our second chain over here, makes with the ceiling, which is over here. So this is the angle we're looking for then. Just like the last question, I'm going to label our vertices just to make it easier for us to name our angles and our sides. And then I'm also going to label its sides. So directly across from angle A is going to be side A. And directly across from angle A gives us side A. Directly across from angle B will give us side B. And lastly, directly across from angle C will give us side C. And it looks like where my question mark is, I'm looking for angle B. Now let's evaluate to see what information has been given to us. We have angle A, we have side A. So that's a pair that we have. We're looking for angle B, but we have side B. So in this case, when I'm writing out my sine law, I'm going to use sine A over A is equal to sine B over B. We're not going to use C at all because you have no information about C whatsoever. So this is sine A over A is equal to sine B over B. Just going to fill in the information we have. So angle A is 55 degrees, which is right here. Side A is 3.5 meters. Angle B we don't know, so I'm going to leave big B alone. And then side B is 2.4 meters. Now my step to solve for this is to isolate sine B and then isolate B. My first step is to cross multiply. So that's the arrowhead 2.4 multiplied by sine 55. And the bottom arrowhead on our left side is 3.5 multiplied by that top arrowhead on the other side, which is sine B. Now I'm going to divide to isolate sine B. So I'm looking for B. So I'm going to divide both sides by 3.5. Now I'm going to put 2.4 times sine 55 divided by 3.5 in the calculator to get some sort of decimal, and then I'll take the sine inverse of both sides to isolate b. Okay, so I'm going to first try to simplify the left-hand side. So 2.4 multiplied by sine 55, then press equals, then divide by 3.5, then press equals again, will give us a long decimal number, 0.5617, and it goes on a bit. Then lastly, to isolate sine b, or isolate b, I'm going to take sine inverse of both sides. So then b then is equal to sine inverse of 0.5617. Angle should be about 34 degrees. And that will be your final answer. So that's it for this lesson. Please try the homework that's after this page and email me if you have any questions.